In previous examples, we've looked at the equilibrium constant changing from a Kp to a Kc, and we looked at what happens if you double the reaction, what happens if you reverse the reaction, when are the products favored, when are the reactants favored, and all this stuff. But in this example, we're actually asked to calculate the Kc. So it says, what is the value of the equilibrium constant for the following reaction if at equilibrium the concentration of CO2 is 1.4 molar, the concentration of H plus is 0.22 molar, and the concentration of HCO3 minus is 0.22 molar. So the first thing we need to do is write the expression for Kc. The only things that go in the Kc expression are things that are gases or aqueous. So in the case of water, which is a liquid, we don't include it. And remember, it's the concentration of the products over the concentrations of the reactants. In this case, all of the stoichiometric coefficients are 1. So in this case, we don't need to raise anything to any power. So let's start with the products on top, which are the concentration of H plus times the concentration of HCO3 minus bicarbonate. This reaction is actually dissolving carbon dioxide in water to form a weak acid, carbonic acid, which is usually done at high pressure, like in a bottle of soda. Now we need to put the products, or we already put the products on the top, now we need to put the reactants on the bottom. And we put CO2 on the bottom. Notice we do not include H2O because it's a liquid. Therefore, since its density is constant, its concentration is constant, or its concentration doesn't change, however you want to think about it, it doesn't go in the equilibrium constant expression. So now we can plug in our values. So in this case, the concentration of H plus is given to us. It's 0.22. And we can ignore units here. Times the concentration of bicarbonate, HCO3 minus, is also 0.22. And the concentration of carbon dioxide is 1.4. So we take 0.22 times 0.22 divided by 1.4, and we simply get 3.5 times 10 to the minus 2. What does this value of Kc tell us? Well, this value of Kc tells us, because it's less than 1, that the that the reactants are favored. So in this case, CO2 is favored. Why? Because there's more CO2 than there is H plus and bicarbonate. And if we look at the numbers, that makes sense. There's more CO2, a higher concentration of CO2, and a lower concentration of H plus and bicarbonate. So in this case, because the equilibrium constant is less than 1, we know the reactants are favored.